Everyone, welcome back to Codera. In this video, we'll discuss the problem B, that is array eversion from the latest CodeForces round 759, which was rated for division 2. So let us quickly read the problem statement. So the problem says that you have been given an array which is of length n, and there is this concept, that is eversion operation, that has been defined. So it says that in eversion operations you choose the last element of the current array, and once you choose that, so what will happen, let's say the last element of your current array is x. So once you choose that element, so all the elements that the array gets divided into two parts. So all the elements which are lesser than equal to x, they will come in the left part, and all the elements which are greater than x, they will come in the right part of that array. And after that, what you will do is the order of elements will remain the same as it was before the operation, and after that you will concatenate the array, right? So let me take this example 2 4 1 5 and 3. Okay, so if I take this example 2 4 1 5 and 3, so in this my x will be 3, that is the last element, which is a of 4, that is my last element. So I'll choose this element, and what will happen, it will get divided into two parts, right? All the elements that are lesser than equal to 3, all the elements that are lesser than equal to 3, so that is 2 1 and 3 itself, right? And notice that I've kept the order same, that is, it is a stable operation that I've performed. 2 was occurring before 1, and 1 was occurring before 3, so that is why I've kept it like this. After that, what I have done is, all the elements that were greater than 3, they will be like this, 4 and 5. So this is how it will look like, right? These are elements that are greater than 3, right? So in this way it will happen, and after that what you will do is, you can say that you will merge this out. So this will look like 2 1 and 3 and 4 and 5 after that, right? So this is how it would look like. This is what in one operation will be done. And what the problem further says is that you start with an array A that has been given to you and perform the eversions on this array, and it can be proved that after several eversions, after performing several operations, the array will stop changing. So you have you have to output the minimum number of operations, that is, let's say k is the minimum number of operations after which the eversions will stop. So you have to print this number k, that is the minimum number of operations in which the array will stop changing, right? And in this, what you will be given, you will be given an integer n, that is the size of the array, and you will be given the elements of the array for each test case. So let us quickly see in this case. In this case, let me draw this case again. So let's say the array that has been given to us is again 2 4 1 5 and 3. So if I give you the array as 2 4 1 5 and 3, that is this array 2 4 1 5 and 3, right? So if this is the array that has been given to me, so I'll choose the last element of the array, and what I will do after that, I'll make two divisions, right? So the first division will be such that the order will be maintained and the elements will be less or equal to 3, as I told you. And in the other part, the elements would look like this, that is, elements greater than 3, elements less equal to 3 in the left part. After that, I'll merge this, and the new array that will form for us is 2 1 3 4 and 5, right? Notice that I have kept the order same, right? Relative order is same for all the elements, right? Except the part that I have performed the operation by taking the left part, all the elements are less or equal to 3, and all the elements greater than 3 are on the right part, right? After that, once I have this, so I'll choose the x again. X is now equal to 5, that is a of 4, that is my last element. So once I choose this 5, so I can see that if I even choose this 5, so nothing else will happen, because all the elements will be coming to only the left part of the array, that is 2 1 then 3 4 and 5, and no element, since no element is greater than 5, so that is why no right part will form, so the array will remain the same. So you can say that in one operation for this given array, in one operation you can say that it is stabilized, right? It does not change, right? I hope that this operation is clear for everyone. Now how does that happen? So for this case, you can see that my 5 here is the maximum element. So you can notice one thing, that if I have the maximum element at the end, then my array will not change, right? Let's say I have any array, let's say a1 a2 a3 up till an, right? So if my an, whenever my an is my maximum element of the array, in that case, after performing several operations, let's say my an is the maximum element after performing several operations, so at that time I will say that my array will stop changing, because since the maximum element will be at the last, so that is why no change will be done in the array, right? Let's take the second example that has been given to us. Before moving, let's say that we have n is equal to 4 and we have 4 elements, that is 1 1 1 and 1. So you can see that since all the elements are same, so that is why nothing will happen, because let's say if I choose this even, so no change will be there, only because the array remains the same, so number of evasions operations that I'll be performing is nothing but 0, right? But the interesting case comes in when I have a test case, like let's say I have n is equal to 5, and let me just see the test case: 5 3 2 4 and 1, right? So if I have this 5 3 2 4 and 1, right? So if I have 5 3 2 4 and 1, so in this case what will happen, I'll choose x is equal to 1, that is my last element. And once I choose this element, so I'll partition this into two parts, right? So this first part will be 3 2 and 1, and the second part will be 5 and 4, right? This will be the second part, this will be the first part. After that I'll merge this, so this becomes what, 3 2 and 1, and after that 5 and 4, right? So once this much part is done, so I have this new array, and in this new array I'll choose x as 4, that is my last element, because that is the definition that has been given to us. I have to choose the last element every time. Once I choose this 4, so what will happen, I'll divide this array again. So this array will look like 3 2 1, that is the relative order will remain the same, and the last element will be 4. So these are the elements that are lesser equal to 4. After that, the element that is greater than 5 is only one element, that is 5. So element that is greater than 4. After that I'll merge this, so the new array will look like 3 2 1 4 and 5. After this, if I choose x is equal to 5, so you can see that since x is the largest element, so after this no change will be done, because if I do this, so even after doing that there will be no right part, because there is no element that is greater than x. So that is why no change will be happening after this operation, right? So I can say that I choose this, first of all I chose an element that is x is equal to 1, and I did the inversion evasion, so this was the first operation, right? And I choose x is equal to 4, and in this way I did the second operation. And after these two operations, I say that I was able to stabilize the array, or I can say that no more operations were able to be performed on this array, right? So that is why the number of operations were 2. But wait, how do you get this point, right? How do you get to such a conclusion? So in this way, in this problem, what you can notice, one thing that you need to notice is, regardless of the fact that whatever has been given in the array, if you have the maximum element at the end, if you have the maximum element in the end, then the number of evasions will stop, right? If that is not the case, so the array will keep on changing. Let me take another case. Let's say I take 1, then I take 2, then I take 4, I take 5, and I take 3, right? So for this, you can pause the video and think what will be the number of evasions. So for this array, what will be the answer? So you can simply see that I have to choose this x is equal to 3. So once I choose this, so what will happen, this array will look like 1 2 and 3, right? So the first part will be 1 2 and 3, and the second part will be what, 4 and 5, right? After this, what will happen, I'll merge these two arrays, and this will look like 1 2 3 and then 4 and 5. So you can see that the answer is what, answer is nothing but after this you can see that no operations can be performed, right? So for this array the number of operations is 1. But wait, how can I determine that, right? So that this is still the question. Notice that one thing, that this was my first element that I took, after that this was the element that I took, and this was the maximum element. So from here the operation stopped. But can I conclude something from this case? No, I cannot. I still cannot conclude anything from this case, right? So let me take another example. Let's say I have one, let's say I have two, let's say I have 5 4 3 2 and 1, right? Let's take the worst case. So if I have 5 4 3 2 and 1, so in this case what will happen, first of all I'll be choosing x is equal to 1, right? Once I choose x is equal to 1, in this case what will, let's say I am just generalizing, taking a normal case, that is this case, okay? In this case what will happen, first of all I take x is equal to 1, right? I take x is equal to 1, and what will happen, only x will be remaining here and the rest of the part will be same, right? 5 4 2 4 and 3, right? This will be the part after the first operation. Now in this case what will happen, in this case can I say that I'll be choosing 3 as well. Yes, I will be choosing 3 as well. Why? Because if my x is equal to 3, so what will happen? The array will look like 1, then 2, and then 3. That is 1, 2, 3. These three elements will be there, and then 5 and 4, right? 5 and 4 will be the second part. So I have just merged them. I have just reduced steps. Now what will happen in this case is, you can see that x, you will say now that x is equal to what? X is equal to 4. So I know that 1, 2, 3, then 4, and then 5, right? So you can see now that once you take x is equal to 5, so now the array will remain the same, it will not change. So I took 1, 2, and 3 operations. But now you must have been thinking up till now that the answer must have been, let's say, 4, right? 1, 2, 3, and 4, that is the number of positions. Some people might have thought that the number of positions that the maximum element is away from, that should have been the answer, while that is not the case. Why that is not the case? Because what happens is, you can see that this 1 was taken, right? After this 3 was also taken, this 4 was also taken. But why was this 2 not taken? Why was this 2 not taken? Because this 4 was greater than this 2, right? You can see this 1 was lesser than this 3, this 3 was lesser than this 4, right? This 4 was greater than this 2, right? This is different. This 4 was greater than this 2. So that is why once you perform the operation taking x is equal to 4, that is when the last element is 4. So in that case, what would happen? My 4, what will happen is, my 4 was the only element that was left. What was the reason for that? The reason was that when my x was 3, so when my x was 3, so this element 2 got carried away with this 3, right? This element 2, instead of going till the end, that is, instead of becoming the last candidate for the last element, it just went with 3. Why? Because it was lesser equal to 3, so it had to go here, right? So that is why you can observe one thing, that the number of changes that you will be performing will be nothing but the answer will depend on the number of changes that you are performing from the end. Why? Because what will happen, let's say you have the you have any array, let's say the array that has been given to us 2, 4, let's say 5, 3, 2, 4, 1, right? If it is 5, 3, 2, 4, and 1, so in this case you will observe one thing, that for this element, will I perform the operation? Yes, I'll perform the operation. Why I'll perform the operation? Because I have to perform for this element, right? After this, will I perform the operation for this element as well? Yes, I have to perform operation for this element as well. The reason for that is pretty simple. The reason for that is, I'll have to perform the operation for this element as well, because one will not take this element, right? When I have x is equal to 1, so x will not take this 4, so that is why this 4 will remain at the end. So that is why it will be the candidate for becoming the x is equal to a of last element, right? This will be the candidate. So that is why I have to perform evasion taking this x as 4 as well. After this, once I take x is equal to 4, so that what will happen, this 2 will get carried away with this 4, right? Since this 4 is greater, so that is why once I take x is equal to 4, so this 2 will get carried away with this 4. So that is why it will never be forming the candidate for the last element, that is x. So that is why I will not take it. And I have to take this 3 as well? No, I don't have to take this 3 as well. Why? Because you might have thought that I have to take this 3 as well, but I don't have to take it, because since my 4 is the larger element, so that is why I don't have to take this 3, because my 4 will carry away this 3 as well, right? What will happen if I take x is equal to 1? Then this array will look like something like this, right? After that, once I take this 4, x is equal to 4, so what will happen is, once I take x is equal to 4, so these elements 3 and 2 and 4, all these will shift towards the right. So that means 1, 3, 2 and 4, and 5 will move automatically to the last. So you might have thought that you needed 4 operations, right? But you didn't need 4 operations, because for this you could do it in 2 operations. Why? Because if there is a bigger number, then the number towards the left of it, if there is a bigger number towards the right and the left element is smaller from the right element, in that case, assuming that the maximum element is still not seen, so that is why what will happen, this element will carry away with this, right? So that is why instead of performing 3 operations, this will be only done in 1 operation, right? This whole complete part will be done in 1 operation, and this one will take 1 separate operation for itself, right? So that is why in this test case you will take 2 operations only, right? So what you will be doing in this case is, let me draw the test case again, that is 5, 3, 2, 4 and 1. So in this case, what will happen is, first of all, you can mark your maximum that you have seen up till now as 0. Now what will happen, once you can keep a counter, that is the maximum number of element that you have seen. So initially your counter will be nothing but 0. So what you have kept is, you have kept your counter as 0. Now you come to this index and you see that you have to take this element, right? So you see that is what is my maximum up till now? My maximum is 0, and my current element from the end is what? Because I have to consider the end according to these operations, right? So the current element from the end is nothing but 1. So since it is 1, so it is greater, so that is why I have to increase my count by 1. My count becomes 1, and my maximum value is now 1, right? After that, I go to this index, that is the second last index, and I see that there is this element 4. So I can see that it is maximum greater than 1, so that it is greater than the maximum up till now, that is it is greater than 1. So that is why I'll update my maximum to 4, and my count increases from 1 to 2, right? After this, I go to this element and I see, is 2 greater than the maximum that I have seen up till now? No, 2 is not greater than the maximum that I have seen up till now, right? So that is why in this case, what will happen, I'll simply say that for this case, I don't need to change, right? So that is why it will not change, right? After that, what will happen once I move to this 3? So I can see that I am moving to this 3, and for this 3 also, my 4, the maximum that I've seen up till now, it is greater, right? So that is why it will get carried away with this maximum. So no, it will not be a candidate for becoming X in this case. So that is why my count will still remain 2. After that, once I move to this element, I can see that I have to update my maximum from 4 to 5, because up till now the maximum was 4, now the maximum is 5. Now my counter is 3. So once I have done this, so you can see that for this case, what was my number of operations that I had to perform? The number of operations that I had to perform was 2, right? We did the dry run for this case, and the number of operations that I had to perform was 2. But why is the count coming out to be 3? The count is coming out to be 3 because for the actual maximum element of the array to become X, from maximum element of the array to become X, it will take three chances, right? In the third chance, we'll be able to determine what will happen when the array looks like, first of all, 1, 3, 2, 4 and 5. When the array looks like this and you take X is equal to 5, then you will say that the number of eversions are not possible, right? So that is why on the third, this means that on the third operation, you will be able to determine that now your array is not changing, it is remaining constant even after performing evasions, that is taking X is equal to the last element. So that is why you will be able to perform only two number of operations such that your array is changing by taking X is equal to the last element, right, and performing the operation. And at the third time, once you come, so you will observe that the last element will be the last element that you have here, it will be here, right? So that is why it will not be able to change. So the in the third operation, you will say that once I have gone to the third operation, so it will not change. On the third operation, the array will not change. So that means that up till the second operation, it will change. So the answer will be nothing but count minus 1, right? Now you will say that we might get an error as well. So that is not the case. Let's say if this is the case, that is 1, 2, 3, 4 and 5. So for this, you will say that the answer is 0. Yes, I will agree to that. The answer is 0. Why? Because the maximum I have marked as 0, and let's say I mark my count as 0 as well. After that, what I do, I move to this index. Once I come to this index, I see that it is greater than my maximum. So I'll update my maximum to 5, and I'll increase my count to 1. Now my maximum is 5. I come to this 4. Is 4 greater than my 5? No. I come to this 3. Is my element 3 greater than 5? No. Is this 2 greater than 5? No. Is this 1 greater than 5? No. So that means that the count is 1. Now you'll say that what does this mean? So this means that 1, 2, 3, 4, 5. So when I perform the first operation, taking the last element, that is X is equal to 5, so I will be able to see on the first operation itself that the array is not changing, right? So that is why the total number of operations, unique operations, such that my array will be changing is nothing but 0, right? That is count minus 1 that I told in the earlier case as well, and it works for this case as well. You can try it out for other cases as well. Now let me show you the code part for this problem. So the code part is very simple. What you will be doing first of all is, you will be having this element, all the elements of the array as an input. Once you have that, so you'll be iterating from the back, because that is what is important in this question. If you will not do that, then you will be getting a time limit exceeded if you will try to do it in a brute force manner, that is order of n square solution. So what you'll be doing is you'll be iterating from the back, and if your a of I is greater than the maximum element that you have seen up till now, notice that you'll be marking your maximum and count as well as 0. So if the a of I, the element from the last, ith element from the end, is greater than the maximum that you have seen up till now, then you'll update your maximum to a of I and you'll count the elements. And since you are counting one more time, that is you are also counting the operation, your count is also storing one more operation, that is the operation in which my array does not change. So that is why in the end I'll only return count minus 1, right? So this was the problem B from the CodeForces round 759. Make sure to subscribe the channel and like the video and give your feedbacks in the comments, and if in case if you have any doubt, please mention that in the comments. Thank you everyone.